This question is coming from May June 18, paper 3, variant 1. This is the fifth question of the paper. In the question, it is pretty evident we are supposed to use integration using substitution. And this is what I was mentioning in the key pointers video of integration, that use substitution method is always evident in the question. So this is exactly what I meant by that. So let us go ahead and solve the first part where we are supposed to convert the x into the theta using this substitution that is given to us. So I always start by rewriting the same substitution that is given to me and then take the derivative of dx and d theta. So it will become dx d theta is equal to, it will become 2 cos theta into the derivative of cos theta, which is minus sin theta. So it will become minus 2 cos theta sin theta. And then I can replace my d theta on the right hand side. So I can just get rid of this over here and put d theta over here so that I can eliminate this dx and put entire this thing over there. Now, if I want, I can convert this to sine to theta as well, but I'll do it if it's required while I'll be converting all of the x's into the theta format. Now, once I'm done with this, I also need to find the limits. Now, to find the limits, I need to find from x, I need to find what is theta. For that, I need to make theta the subject of formula. So for that, I can just write limits over here. And then I'm trying to find theta is equal to square root of x, but it could be plus and minus square root of x both. And then you're having cos theta is equal to this. Now we know that theta is going to lie in between pi by 6 and pi by 3, which is like 30 to 60. It means you are in the first quadrant. In first quadrant, your answer will always be positive. So you can take positive square root of x over here. So I know that theta will be equal to cos inverse of square root of 1 by 4. And let's call it as theta 1. Let's call this as theta 2. This is cos inverse as square root of 3 by 4. Let's see what kind of answers do we get over here for the theta. So cos inverse of square root of 1 by 4 is nothing but 1 by 2. This comes out as pi by 3. So when x was 1 by 4, we got theta as pi by 3. So at 1 by 4, we got the upper limit. So I'm assuming that in the upper limit, we will be getting this lower limit. But why did we get this other way around? Shouldn't it be 1 by 4's limit on the bottom and 3 by 4 limit on the top? I'll tell you what is the reason behind that in a couple of seconds. But for now, let me go ahead and use my calculator to get square root of 3 by 4. Oops. Cos inverse of square root of 3 by 4. It comes out as pi by 6. Whenever you will rearrange from this format to this format, there will be a negative outside. And whenever you are having a negative outside of the integration, you can always switch your limits to convert this negative to positive. Because let's just say that if you put your answer as it is and your answer came out to be negative, it will come out as positive if you just flip the limits. Right? If you do a minus b, you got answer as negative. But if you do b minus a, answer will be positive. So that kind of thing is what we are doing. We are rotating the limits by multiplying the entire integral with the minus sign. So this is something that we learn in AS level itself. So yeah, I think that is the kind of an approach that we might be taking over here. And this minus sign is what making me think about that. But let's see. I'll go ahead and solve it further. I'm just going to replace everything now in format of theta. So I started with I is equal to from 1 by 4 to 3 by 4 square root of x over 1 minus x dx. This is now same as writing integration from, on the bottom it will be pi by 3 for now because 1 by 4 was on the bottom, so pi by 3 will be on the bottom, pi by 6 on the top. I know it is different than this, but I'll tell you how you can change it. And in place of square root, it is square root only. In place of x, it is cos square theta. And 1 minus cos square is sine square theta. And then this is multiplied with minus 2. I can just write minus 2 outside the integral and then multiply this with cos theta sine theta. And then d theta at the end. How can we simplify it further? So over here, because there is a negative sign, I can flip the limits and convert the negative to positive. So now directly it will become pi by 6 to pi by 3. Then 2 is outside. Then square root of cos square by sine square will become cos theta by sine theta. And then we have to multiply cos theta with sine theta as well. And you can see that the sine theta gets out. And eventually we will be getting 2 cos square theta as we wanted. And the limits are also sorted as we wanted. So therefore my I will be equal to integration from pi over 6 to pi over 3 of 2 cos square theta d theta. And yes, that is how we prove this particular part. Now, once we are aware about that I is equal to this, the next part would be to find the exact value of I. How can I do this? Because I am given the cos square theta, if you remember from my key pointers list of how do you integrate the cos square theta alone, you use the double angle formula for the cos. This is also written in your integration roadmap over here, that if you're having sine square cos square, think about using the identities. So over here, I know that my cos 2x is equal to 2 cos square x minus 1. I need to integrate this, so I'll just send plus 1 over here. So my 2 cos square x is simply equal to cos 2x plus 1. I am supposed to integrate this, but instead of that, I'll integrate this part. So to start with, I'll just give a heading that this is the second part of the question. And my I will be integrated as cos 2 theta plus 1 d theta. And the limits are going from pi by 6 to pi by 3. And from here, I can simply say that the integration of cos is sine. So sine 2 theta, and because of the reverse chain rule, I will also divide this by 2. And then plus 1, the derivative, the integral of that will become theta. Please excuse me if I have said derivative anywhere in the video in place of integral. And then I need to put the limits from pi by 6 to pi by 3. And because I wanted to find the exact value, let's see how do we get this. So what is sine of 2 pi by 3? Let's check. Always make sure your calc is in the radians mode. It is square root of 3 over 2. So this will become square root of 3 over 4 plus pi by 3, and then minus, it will become sine of pi by 3 because 2 pi by 6 is same as writing pi by 3. So if I do sine of pi by 3, it is square root of 3 by 2. Wait, square root of 2 pi by 3 is also square root of 3 pi by 2, and square root of, what am I saying? Sine of 2 times pi by 3 is also this, and 2 times pi by 6, let me check, is also 3 by 2. Yeah, both are root 3 by 2. All right. So this is also square root of 3 by 4 plus pi by 6. I just hope I did not make any kind of an error. But you know my habit. I always cross-check the moment I write something. But yeah, we are also having the second way to check by doing the integration at the end. But anyway, for now, I can see that this and this gets cancelled out. You are having pi by 3 minus pi by 6 as your answer directly. So pi by 3 minus pi by 6, let's see what do we get. If your calc is not capable to solve this directly, you can do 1 by 3 minus 1 by 6 and then just multiply your answer with pi. So I got pi by 6 as my final answer in the exact format. Now let me see if this is correct or not using my calculator. So integration of 2 cos x, and then I have to square the cos term. So I'm putting a bracket on that and having a square. Oops, I don't want to have a square over there. I want to have a square over here. So I'll just get rid of the square from here, and the limits are from pi by 6 to pi by 3. The answer comes out as math error. I hope I have not done some kind of a problem while writing this. It is 2 cos x the whole square. Yeah, pi by 6 is what we are getting, and eventually that is exactly what we have got over here.